positive integer if n has odd number of divisors except 1 and n, then n is a perfect square. We have to prove that n is a perfect square when n has odd number of divisors except 1 and n. We try to solve this, and also we solve this by using method of contradiction. We use the method of contradiction to solve it. Now, suppose n has odd number of integers. We assume n has odd number of divisors. Except 1 and n, but n is not a perfect square. Is not a perfect. We assume n has odd number of divisors except 1 and n, but n is not a perfect square. We assume that n is not a perfect square. Now, if we take the prime factorization of n, we take the prime factorization of n. What is prime factorization? That n has n has factors which are all prime numbers and they are in some powers. So we take n as a prime factor, n as a prime factorization. We take prime factorization of n. So n equal to this is the prime factorization of n. Here p1, p2, p3, pn all are prime numbers. Here p1, p2, pn are all prime numbers. And a1, a2, a3, an are all positive integers. a1, a2, a3, an are all positive integers, and p1, p2, p3, pn are all are prime numbers. This is the prime factorization of n. Now we have chosen n is not a perfect square. N is not a perfect square. So we can say among these powers, that is a1, a2, a3, an, at least one is a even number. At least one is odd number. Now n is not a perfect square. We have chosen it. We have chosen that n is not a perfect square. So among at least one among a1, a2, n is an odd number. As n is not a perfect square, then at least one of them, at least one of the powers of p1, p2, pn is an odd number. As n is not a perfect square. So number of factors of n, number of divisors, so number of divisor of n is, from permutation combination we can get number of divisors is a1 plus 1, a2 plus 1, a3 plus 1, an plus 1 minus 1, n plus 1 minus n and 1 is not the factors of this of n, so it can be excluded from these factors. So we take minus 2. We add it. We add minus 2 with it. That we subtract 2 from this number of factors. Generally, number of factors is a1 plus 1, a2 plus 1, a3 plus 1, n plus 1, including 1 and n. If we exclude the factors 1 and n, so the actual factors, number of factors of n is a1 plus 1, a2 plus 1, a3 plus 1, n plus 1 minus 2. This is the number of divisor of n except 1 and n. Except 1 and n. So as at least one among a1, a2, a3, an is odd number, so at least one among a1 plus 1, a2 plus 1, n plus 1 is an even number. Since at least one among a1, a2, a3, an is an odd number, so at least one among a1 plus 1, a2 plus 1, n plus 1 is an even number. So the number of divisor is multiple of 2. So number of divisors of n is multiple of 2, that is even number of n is an even number. As at least one among a1 plus 1, a2 plus 1, n plus 1 is an even number, so number of divisors is also an even number, that is multiple of 2. But it contradicts our assumption. We assume that n has odd number of divisors. So number of divisor of n is an even number, so it contradicts our assumption. Our assumption was that n has odd number of divisors, but here we have got that n has even number of divisors. So it contradicts our assumption. So our assumption is wrong. Hence, our assumption is wrong. So our assumption is wrong. So we can say n is not a perfect square. So n is not a perfect square. Is false. So n is a perfect square. N is a perfect square. So n is a perfect square. So n is a perfect square. Thus we have proved that n is a perfect square